Welcome to this session. Today we are going to discuss planar graphs and its properties. What is a planar graph? A graph G is said to be planar. G is said to be planar if it can be drawn on the plane or on a sphere so that no two edges crosses each other than the non-vertex, other than the vertex. So here a graph is said to be planar if it can be drawn on a planar, on a plane or a sphere so that no two edges cross each other at a non-vertex point. So here if you draw edges should meet only at the nodes, intersect only at the nodes only. So the remaining places, the edges should not be intersect each other. So here let us consider a graph is this, and here no edge is intersect other than the node itself. See here at this node, the edges are intersecting. In the other places, the edges are not intersect. So this is known as a planar graph. Suppose if you are going to consider another graph is like this. Now this graph is, we are going to say that the graph is like this, and here this is a vertex, edges are intersecting at a non-vertex, so that we can say that this graph is not planar. This graph is not planar. Suppose if you are having like this, any graph is like this. Suppose if I am going to connect internally and externally if I am going to connect, no problem. And here one more edge will be there. Let us, I am going to consider here, and it is not possible to write as well as interior or exterior, as I can write like this also, I can write. So the graph is also the planar graph. The graph I can write. The graph is the vertex is okay. It is not. This graph is a planar, but here we are going to discuss. This is I am going to take this edge. I can connect in the exterior side. So if I am going to write like this in another way, I am going to connect like this. So we can say that. So I am going to say that this is E1, this is E2, and this is E3, and this is E4, and E5, and E6, and E7 will be there. So I cannot connect to the interior E4. I am going to connect to the exterior nodes. Then also this will become a planar graph. This will become a planar graph. So if it is not possible to write, suppose if I am having one more edge is like this, or else I am going to connect one more edge in this manner, then it is not a planar. So here a planar graph is nothing but if you are going to divide the two-dimensional plane into the regions in such a way that no two edges are cross over each other other than the vertex. Now this planar graph will divide the plane into regions. So here, what is a region? The planar representation of a graph split the plane into the connected areas called regions of the plane. So the planar representation of the graph splitting the plane into different areas. Let us say this is one area, this is another area, this is another area, and this is another area. So this is we are calling it as a regions of the plane. And now the degree of the region R1, let us say the degree of the region R1, which is nothing but number of edges enclosing that region. Enclosing the region. That means number of edges are required to get the region. That is known as the interior region or degree of the interior region. And now, what is the degree of the exterior region? Number of edges exposed to that region. Number of edges exposed to that region is known as a degree of exterior region. So here we are going to find what is the degree of the regions. If the region is interior or the exterior, then we are going to find by taking another example. So here, let us, I'm just taking this. So here, I'm just considering this is a planar graph and it is going to divide the plane into the regions. So let us say R1, R2, R3 and R4. So now, from this planar graph, how I am going to calculate degree of R1? So degree of R1 is equals to how many edges are bounded with this region, how many edges are required to get this region? 3. So I am going to get 3. So this is bounded by 3 edges. R2 if I am considered bounded by 3 edges. So it is nothing but 3. And the degree of R3, it is also bounded by 3 edges. So now this is also 3. And the next degree of R4. So all these regions are interiors. All the regions are interiors. Now we are going to find the exterior region degree. Exterior region degree. So how we are going to get this region? Because of all the edges which are covered, the R1, R2 and R3. So here 1, 2, 3, 4, 5. So here these are the edges. This is bounded other than these edges. So here 1, 2, 3, 4, 5. So the degree of R4 is equals to 5. The degree of R4 is equals to 5. Now, what is some of the properties of this planar graph? So one is degree of each and every vertex is equals to 2 into total number of edges in this graph. This is nothing but the handshaking property. And now, see here if you are going to add all the degrees of regions. So here I am going to write degree of R1 plus a degree of R2 plus a degree of R3 plus a degree of R4. R3 plus a degree of R4. What I am going to get? So it is 3 plus 3 plus 3, 9 plus 5. It is equals to 14. So 14 can be written as 2 into how many edges it is having? 1, this is 1 edge, 2 edge, 3 edge, 4 edge, 5 edge, 6 edge, 7 edges. So it is a 2 into 7. So number of edges in the graph, number of edges in the graph. So that is another property. Sum of the degrees of all regions, sum of the degrees of all regions must be equal to 2 into total number of edges in the graph, total number of edges in the graph. So degree of all regions, sum of the degrees of all regions, which is equals to 2 into number of edges, 2 into number of edges. So this is another property. Now, let us suppose if I am going to consider, let us say that the degree of the region, I am going to take k, the degree of each and every region, the degree of each and every region. Suppose degree of R1 is equals to k1, degree of R2 is equals to k1, k1, and the degree of R3 is equals to k1, and the degree of R4 is equals to k1. Then the sum of the degrees of, that means which is equals to sum of the degrees of all regions, I is equals to 1 to 4 is equals to 2 into, that means we are going to consider it as, that k into r. R is nothing but how many times it is going to be repeated. It is repeated 4 times. So we are going to get it as 4 into k1. 4 into k1. In the similar sense that we are going to consider. So the 2 into number of edges are k into r. K is nothing but the number of regions. And the each degree region is k, and there are r regions. There are r regions will be there. So k into r is equals to 2 into cardinality of E. Cardinality of E. And suppose, let us consider, I am going to take, I am going to consider one example. I'm just taking, so any graph, let us say, I'm going to consider the graph is like this. Let us say, this is the planar graph. So here the planar graph does not have any intersecting these things. So here I am going to get. Now, let us say that there are R1, R2, R2, R3 and R4 reasons. 4 reasons are there. So, degree of R1 is greater than or equal to K. Greater than or equals to K. And degree of R2 is greater than or equals to K. Degree of R3 is greater than or equals to K. Degree of RR is greater than or equals to K. So the sum is degree of R1 plus degree of R2 plus and so on, degree of RR is greater than or equals to how many times it is repeated? R times it is repeated. So RK. And this is nothing but 2 into number of edges. 2 into number of edges which is greater than or equals to RK. Which is greater than or equals to RK. So RK is less than or equals to 2 into number of edges. So this here we are going to write like this. So KR, K into R. That means the K is nothing but the degree of each and every reason, and there are R reasons are there. So KR is less than or equals to 2 into cardinality of E. That is nothing but number of edges. Suppose if I am going to consider the next one, if degree of R1 is less than or equal to K and degree of RR is less than or equal to K, so then this is nothing but degree of R1 to degree of RR. So degree of RR is less than or equals to RK. So it is 2 into, and then it is nothing but 2 into number of edges which is less than or equal to RK. So RK is greater than or equal to 2 into cardinality of E, or number of edges. So that we are going to represent this. So this is similarly we can write it as KR is equals to 2E cardinality of E. Or this I am going to write KR is less than or equals to 2 number of edges. So this is KR is greater than or equals to 2 number of edges. So these are in a planar graph, if we are going to divide, if we are going to get the reasons are degrees reasons, if they are given in a constant number, then we are going to consider the first one, otherwise we are going to consider the second and third one. Now the third property third. So here, what is the relationship between the edges, vertices and regions? The relationship between vertices, edges and regions. So that is known as a Euler's formula. So in any G is a, let us consider G is a connected planar simple graph with E edges and V vertices, and it will generate R regions. Then the relationship between the number of regions, number of vertices and number of edges are, this is the reasons and relationship, and this is known as Euler's formula. It remains the same in all the planar graphs, planar representation of the graph. So this is true for all the planar graphs. So this is the Euler's theorem. And another property, if G is a planar graph which is having k components, then we are going to take the relationship as like this. So R is equal to E minus V plus K plus 1. So these are the 4 properties that we have on the planar graphs. Now let us go for what are the properties of the planar graph. Let us consider the properties are, if G is a planar graph and which is having E edges and R regions, then G is a connected planar graph, which is having E edges and R regions, then R is less than or equals to 2 by 3 into E. 2 by 3 into E. This is one of the property. And of course, Euler's theorem, second property is the Euler's theorem we are going to write. And then the another one is that whatever the properties so far we have discussed, and we are going to write all the properties in the summarized way, and we are going to add one or two extras will be there. And if G is a connected planar graph, and if it is having E edges and V vertices, then the relationship is, then it is nothing but 3V minus E is greater than or equals to 6. So whenever, if a connected planar graph has E edges and V vertices, then what is the relationship is between the vertices and the edges is, this is the relationship. And here the regions and edges is that is the relationship. And now a complete graph with n vertices is a planar. Complete graph with n vertices is a planar if and only if the number of the vertices is less than 5. Number of vertices are less than 5. If a 5 is there, then it is not a planar graph. And if number of vertices are 4, then it is a planar graph. Number of vertices 4 is, this is let us say, what is a complete graph with 4 vertices? 4 vertices I am going to connect like this, and I am going to connect another edges like this. So this I am going to represent like this. So this is K4, and next K3 is. So here 3 vertices will be there, and I am going to get this as the complete graph with 3 vertices. So it is also will give a planar graph. So that we can consider a complete graph with n vertices is planar if and only if whatever the number of vertices is less than 5 only it is planar. Otherwise, all complete graphs greater than or equal to 5, they are non-planar. Now, the another one is a complete bipartite graph. Complete bipartite graph is a planar if and only if m is less than n or n is greater than 3. M is less than 3 or n is greater than 3. So then only this condition is true, then we can say that the complete bipartite graph is a planar. Otherwise, it is not planar. So let us go to discuss some of the problems. Now here, prove that K4 is a planar graph. Prove that K4 is a planar graph. So K4, how many vertices it is having? The number of vertices is 4 vertices. 1, 2, 3, 4. And how many edges it is having? 1, 2, 3, 4, 5, 6 edges it is having. 6 edges it is having. Now, we know that a connected planar graph, then 3V minus E is greater than or equals to 6 because of the above property. There is a relationship between the vertices and edges. Now here, vertices I am going to substitute 4 vertices and edges I am going to substitute 6. So subsequently 3 into 4 minus 6. So which is equals to 12 minus 6 is 6. So 6 is greater than or equals to 6. So the condition is satisfies. So we can say that K4 is planar. K4 is planar. So this is completely based on the third one. If G is a connected planar graph which is having E edges and V vertices, then 3V minus E is greater than or equal to 6. So from that we can say that then the graph is a planar. And suppose if I am going to consider another graph, a Kurtoskis, that is a complete graph with 5 vertices. So I am going to get, this is the Kurtoskis first graph, or we can say that complete graph with 5 vertices. So here, one way we are going to represent, we can draw the edges. All the draw the edges, either we are going to connect. Suppose if I am taking this edge, I am going to connect like this, external. So there is no intersection. And this edge I am going to connect. I am going to connect like this. And what about this edge? This edge, it is not possible for me. This edge, sorry, here it is not there. I am just connecting this. So I am going to take like this. This I am going to take like this. Externally I am connected. And this edge, if I am going to connect it externally, it is not possible. It is going to be intersecting at this point. And internally, if I am going to connect, then it is going to be intersecting at these 2 points for these edges. So, this Kuratowski's first graph is not possible to draw in such a manner the edges will not cross over each other than the vertex. So, we can say that the graph is the planar graph with 5 vertices. The complete graph with 5 vertices is not a planar graph. Or directly from this property, we can say that which is not a planar. Otherwise, we can say that how many vertices it is having? 5 vertices it is having. V is equal to 5. And how many edges it is having? Let us say the number of edges are external edges are 1, 2, 3, 4, 5, and next 6, 7, next 8, 9, then the another one is 10. So, number of edges are 10. Then I am going to take that 3 into V, 3 into 5 minus 10. So, what I am going to get? 15 minus 10. So, which is equals to 5. Then, which is not equals to greater than or equals to 6, which is not true. So, we can say that the given graph is not planar. One way is by drawing that. Another way is by taking this condition, and we have to verify if the condition is true, then we can say that it is planar. Otherwise, it is not planar. Now, what is a properties of a non-planar graph? So, a graph is non-planar if and only if it contains a subgraph homomorphic to K5 or K33. So, if I am going to get any subgraph from the given graph, which is a complete graph with 5 vertices, or a Kuratowski's second graph, that is nothing but complete bipartite graph, if I am going to get from the original graph, then we can say that the graph is a planar graph. The graph is a non-planar graph. Suppose we are going to consider, see the earlier, this is the example, whichever we discussed in the earlier. So, in the same way, we can say that this is already, we discussed here in this manner by using the property, and the same way we are going to discuss here. And the next one is, see here, show that the graph showing below is a non-planar by finding a subgraph which is homomorphic to K5. So here, this is the given graph, and I am going to remove some of the edges. I am going to remove the sum of the edges. If it is reduced, that means I am going to find out a subgraph. Subgraph is nothing but I am going to remove any number of edges or any number of vertices, whatever the graph that I am going to get, that graph is known as the subgraph. Now here, V1 to V4, then I am going to remove this edge. V3, V4 I am going to remove. V3, V4 I am going to remove this edge. And V5, V4 I am going to remove this edge. So finally what I am having, if I am going to remove that edge, so what I am going to get? So this is nothing but, see how many, 1, 2, 3, 4, 5, 6. 6 edges are there. 6 vertices are there. If I am going to remove one more vertex and all its adjacencies, then also we can get, let us say, V1 and V2, then V3, and let us, I am going to consider in another way, V4 and V5. Let us, I am going to connect V6 and its adjacent vertices I am going to remove. So let us, I am just considering V5. So now it is having a 5 vertices, and now V1 to V5, V6 is there. V1 to V4, V1 to V5 and V1 to V4. And V1, V2, V3, V4, V5, V6 I removed. So all the adjacent edges also I removed. Then what about V3? V3 I am going to get, V4 I am going to connect. V1 is already connected, V1 and V2 is I am going to connect. Then if I am going to consider V5 to V3 is there, V4 is there and V2 I have to connect. Then V4 already connected are there, V2 already there, V2 this already there, each and every vertex degree is 4. Now I can say that it is a complete graph with 5 vertices. So the graph is having a subgraph. The graph is having a subgraph, which is a complete, complete graph of 5 vertices. Then the original graph, I can say that it is a non-planar. It is a non-planar. Or suppose if I am going to have another graph, let us say I am going to take this graph. Let us say this is the complete bipartite graph I am going to draw. Now I am just taking connecting, and now it is. See, this is the complete bipartite graph. So suppose if I am going to consider another graph which is like this, and another graph I am going to connect like this. So here it is not a complete bipartite graph, and I am going to remove this vertex and this vertex and its adjacent edges and its adjacent edges. Then whatever the reduced graph is a subgraph, and I am going to get like this, which is nothing but a complete bipartite graph. Complete bipartite graph is non-planar, so we can say that the given graph is also non-planar. So here the basic thing is, one is complete graph with 5 vertices is non-planar, and bipartite graph. So here bipartite graph is a planar or not, that we are going to consider by using this property, third one. Once again, 3v minus e is greater than or equals to 6. 3v minus e is greater than or equals to 6. So here, how many vertices? 1, 2, this is 3, 4. So the cycles are formed with the, so how many vertices? It is 6 vertices, and edges are, each are 3, 9. So it is 3 into 6 minus 9. So which is formed by the, a cycle is going to be formed by here 1, 2. Then so a cycle, how I am going to find this is this one and this one and this one. So cycle is formed by 4 edges. So here cycle is formed by 3 edges. So this condition is there for any graph in that the planar, in that the reason we are going to get by reason by formed by 3 edges, then this is the condition. If it is going to be formed by 4 or other number of edges, then we have to verify by taking the other conditions. And here, so while we are going to take the complete bipartite graph, okay, I am going to connect like this. So this is, so here there is no edges are connected, and I am going to connect in another way, and I am going to connect in another way. And now for this, it is not possible to connect without crossing of the edges. So we can say that this is not a planar graph. So these are the some of the properties on the planar graphs. And now we are going to solve some of the problems based on the planar graphs. Now let us go for that. Problem 1. G is a connected planar graph with 25 vertices. So here V is equals to 25. Number of vertices are 25. And edges are 60. Find the number of regions. So the relationship between the vertices, edges and regions are, then we are going to consider This is the relationship. So now E minus V. So this just to substitute this. So it is 60 minus 25 and plus 2. So it is nothing but 60 minus 23. So we are going to get 37. So 37 reasons are possible in this case. And now let us go for the another problem. GB a planar graph with 10 vertices. And it is having 3 components and 9 edges. Find the number of reasons. So here, if it is having a components are given, k components are given, this is the relationship between number of vertices, number of reasons and edges. So in this we are going to substitute number of vertices are 10 and a number of edges are 9 and a number of components are 3. Just we are going to substitute here, and then we came to know how many reasons that we are going to obtain. So G is equal to 3 reasons. So we are going to get a number of reasons are 3. Now go for the other problem. GB a connected planar graph which is having 20 vertices, and next each vertex degree is 3. There are 20 vertices are there, 20 vertices, and each vertex degree is 3. Then find the number of reasons. So here edges we don't know. First of all, edges we have to calculate before going for the number of reasons. Number of reasons are, this is the relationship. Now I required how to find out number of edges. So here number of vertices are given, and each and every vertex degree is 20. So sum of the degrees of all vertices, each is nothing but, so it is 20 into 3. So it is 60. Sum of the degrees of all vertices, which is nothing but by handshaking property 2 into number of edges. So it is nothing but number of edges are, let us say 30. 60 by 2, it is 30. So E is equal to 30. The number of edges, how many number of edges are there in the graph is 30. Then we are going to find how many reasons it is having. So just we are going to take the Euler's formula. R is equals to E minus V plus 2. And R we have to calculate. E is equal to 30 and the vertices are 20 plus 2. So it is nothing but 12. There are 12 reasons will be exist for a graph is having 20 vertices of the degree sequences of the degree of each vertex is 3. Then the another one. Let G be a connected planar graph with 35 reasons. R is given. R is equals to 35. Degree of each reason is 6. Then there are 35 reasons are there. Degree of each reason is 6. Find the number of vertices in the graph. So here, find the number of vertices in the graph. Now first this is also, we have to find out how many vertices it is having. So here it is given, reasons will be given, each and every degree vertex is given. So I am going to calculate sum of the degrees of all reasons. Ri. I is equals to 1 to 35. Is equals to 2 into number of edges. So each and every vertex degree is 6. There are 35 reasons are there. Each and every reason degree is 6. So 6 into 35. There are 35 reasons are there. Each reason degree is 6. So which is equals to 2 into number of edges. So it is nothing but 2 3 ja. So number of edges are, so it is 15 105. Number of edges are 105. Whenever, if you have the number of edges are 105, then we are going to find out for finding the vertices, and they take the Euler's formula. That is nothing but R is equals to E minus V plus 2. Just taking that and we are going to substitute. R is equals to 35 and E is equals to 105 and what is this that we have to calculate, and if you are going to simplify this, then we are going to get the number of vertices are 72. Number of vertices are 72. So this is the last problem is just we are finding the number of reasons whenever degree of each and every reason degree is given, and there will be a number of vertices are given. So here number of vertices we have to find out, only number of reasons and a degree of each and every reason is given. Now the another one. So GBA connected planar graph with 12 vertices. Number of vertices are given and the number of edges are given 30, and degree of each reason is k. Find the value of k. Find the value of k. So we have to find out what is the value, what is the degree of each and every reason. Each and every reason. So we are going to find out the degree. So what is the sum of the degrees of vertices? Sum of the degrees of all reasons. Sum of the degrees of all reasons must be 2 into number of edges. 2 into number of edges. So degree of each reason is k. Each reason is k. How many reasons are there? There are 12 and 30 edges will be there. Then the degree of each reason is k. Find the value of k. Find the value of k. So here we are going to consider the number of reasons. How many number of reasons? If we know, then we are going to substitute here on number of reasons. If you are going to know, then we are going to multiply the number of reasons with k. Subsequently we came to know this. So here vertices will be there, edges will be there. How to find out the number of reasons? By Euler's formula. This is R is equals to E minus V plus 2. Just to substitute, E is equals to number of edges 30 minus 12 plus 2. So it is nothing but 32 minus 2. It is 20 only. So there are 20 reasons. There are 20 reasons. Each reason degree is k. So this is the sum of the degrees of reasons are 20 into k, and which is equals to, by handshaking property, this is 2 into number of edges. So subsequently 2 into number of edges, how many edges it is having? 30 edges. It is nothing but 20k. So 3 to get cancelled, and then this is cancelled. So each and every reason degree is 3. Each and every reason degree is 3. So whenever if you are considering a planar graph with 12 vertices and 30 edges, and each and every reason degree, there are k reasons will be there, and each and every reason degree is given already, each and every degree reason is given, which is equal to k, that k value is equal to 3. K value is equal to 3. Now, find the maximum number of reasons are possible in a simple planar graph with 10 edges. With 10 edges. So let us, we are assuming that it is having r reasons. R reasons. Let us say we are going to assume it is having r reasons. What are those reasons? R1, R2 and so on, RR. So what is the maximum number of reasons? Maximum number of reasons are possible here. Maximum number of reasons are possible in a simple planar graph. Simple planar graph. That we are going to calculate what is that R reason. What is that R? So here by using it is a simple planar graph. So it is a simple planar graph means each and every reason that we are going to get by the form of 3 edges. 3 edges. So each and every reason degree is 3 we are considering. So 3 into each and every reason degree is 3. There are r reasons. So 3r is equals to 2 into number of edges. Number of edges. So it is equals to 10. So R is equals to, then we are going to get 20 by 3. 20 by 3. So it is nothing but 6.666 something. So 6.67 we are going to get. So it is now, it's a fraction. So what is the maximum number of reasons? This is, we are going to take it as a floor of this. So we are going to get 6. We are going to get 6. So maximum number of reasons are, we are going to get the 6. Now, what is the minimum number of edges are necessary in a simple planar graph with 15 reasons? 15 reasons. So minimum number of edges which are required, minimum number of edges are required with 15 reasons. 15 reasons. Once again, the same way, we are going to assume the number of edges are E. Let us say number of edges are E. Then by using, so there are how many reasons are there? 15 reasons are there, and it is a simple planar graph. It is a simple planar graph. So each and every reason is formed by degree 3. So there are the sum of the degrees of vertices is 15 into 3 is equals to 2 into number of edges. 2 into number of edges. So it is 30, which is equals to, we are going to 45 is equals to 2E. So then E is equals to 45 by 2. So it is nothing but 22.5. So what is the minimum number of edges that we have to consider is, it is nothing but the minimum number of edges is, we are going to consider 20. What about this? So it is a maximum number of reasons. Okay, 6 here. The number of edges are, minimum number of edges are only 22. Just it is going to be considered as 22. So E should be greater than or equal to is so it is nothing but 22. So now this is the substituting R value. It is nothing but 45. Okay. So here one more condition will be there. So each and every vertex degree is 3. Some reasons we are going to get by 4. So what we are going to write, sum of the degrees of all vertices. So this is nothing but which is less than or equal to, I have to keep less than or equal to. So which is less than or equal to, which is greater than or equal to, right? Which is greater than or equals to. So great number of edges are greater than or equals to 22.5. So the minimum edges are required as 22. That is the planar graphs and its properties and related some of the problems. With this, we conclude this, and the next session we are going to discuss. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.